Please make sure to state clearly what you took away from this lecture and what you have learned, just as much as the stuff that is still a little bit muddy to you and what you can do to get clarification on it, so that we can now move on to our actual understanding that we should have gained from this lecture. First of all, we started the lecture by expanding the knowledge that we had from 2D systems and moved it into 3D systems. And I believe we can clearly say that we understand how that works. Then we talked about the different formula that describe how a vector product is defined and how we can calculate it. And of course, we are now able to use the vector product and to calculate moments, or what you have been referred to as torque. Now, I think I also made clear why it's best that you should actually use a visual method to calculate your vector product determinants, because it's just easier for us to see your mistakes. And if you work in the real world, it's also easier for other people to understand your steps or your mistakes. And in the case of this class, it's obviously easier for us to give you as many points as we possibly can. Then we, of course, learned how to interpret the 3D results. That is very important to me in the context of this lecture. So I hope that I got that point across to you, and that you can now, if you have to, properly graph the 3D moments. And then last but not least, we hopefully understand that moments are always 3D vector phenomena. They cannot be not directed, so they have to be a vector. So you will always include three results. You will include the magnitude, the components, which is ijk, and the directional angle or the unit vector. And we have done that in every example that we have solved in this class so far, so I think that should not be a surprise. But that concludes our concluding page, and we are now ready to move on to the homework. Let's go ahead. So here we can see our upcoming homework problems, and to no surprise, it's very similar to what we have done in class. Let's take a look at the very first problem. You have a structure that goes from A to B, and it's described with different dimensions here. You have a force given to you, and that force can be used with the lever arm that we called R, and then you can calculate the moment that is acting at point A. I don't think that needs any more explanation here. Now for point B, or problem B, it's kind of the same thing, just that the force is given in a different description here. So F4 is acting at B, and you need to find the moment about point O due to that force. Now you have to break down this F4 force based on the geometry, and we practiced this many times in this class. So you have a height of 2 feet here, 4 feet, and then this is A and this is D, and that really can help you to form, if you want to use a unit vector, you can use the unit vector here, and that forms then the force along this cable. So you can really describe this force using either unit vector or similar triangle. It's up to you, but the bottom line is you use that ijk component of that force and cross that with the lever arm. Let's move on to the third problem, which looks like fun. The only difference here is that the force is now given with our standard description with these planes, right? So the force here is alpha downwards. So from this xy plane, maybe I should write this in here real quick. So this is parallel to y and this is parallel to x. And when I say this, let me explain that. So here we have x, and then we have y along this line. And that line is alpha degrees away from the xy plane, if you will. And so you can project this force up to the xy plane. And then once you have this, let's call this diagonal, you can project it with 40 degrees onto the y direction. And then also onto the x direction. And then, as for all of these problems, all you have to do is find the moment due to the distance between the force and the origin of the coordinate system. So that is that problem C. Let's look at problem D, which is a lot of fun because it looks like a lot of work initially, but maybe once you start it, you will be convinced that it's not that bad. You have given F2 here, F2 here, and then here you have F1 and you have F1 here. Dimensions are given, and what you have to do is find the resultant moment, right, due to all these forces at the anchor point O. And again, it may look like a lot of calculations first, but you may want to notice that F1 and F1 are actually acting opposite to each other, right? And F2 and F2 act also opposite to each other. So maybe there's something you can learn from that. That is all the homework problems that you have to solve for this. So I don't think that's too much. You're welcome. I only gave you 4 problems. How nice is that? I think that will allow you plenty of time to study for your upcoming test, because now we are at the end of part 1, and everything that we covered up to this point will be part of your test 1. So good luck studying with that. Please note that there's a study pack online as well. But if you have solved all your homework yourself, I think you are very well prepared to finish these type of problems and finish your preparation for your upcoming exam. I wish you good luck, and I see you in the next lecture. Stay safe.